Hello everyone, I'm Flavio Brancato. I'm a research engineer at EPFL. And so the outline of today, it's basically this. I will talk a bit about the institutional interests regarding the space logistics topic. I will briefly introduce what TCAT is and what are the development of this tool. So I will mainly talk about the institutional interests of the European Space Agency, since Switzerland is one of the contributors to the budget of ESA. So as you can see here in this picture, sorry for the low quality, we have a lot of components, right? We have a constellation here, a geosatellite, a refueling to the space station, kick stages, and also a lot of other parts. So as you can see here, the near future it's quite complex. So there is a need to try to find a way to make this complexity more simple. So the main needs from the side of the agency are these three, I would say: the competitiveness, standardization, and versatility. This means that the main objective is to lower the cost, maximize the interoperability, to reach also all of different kind of orbits with the same launch, for instance, or using some sort of launch services after the launch part. And to do so, the space logistics will help in this needs. So the way space logistics we should help is to match and optimize the use of currently existing space transportation solutions, but also to provide some suggestions on the use of new space transportation services. And to do so, we also want to reduce price and increase the European competitiveness in the space field. And of course, as we really care about this topic, we want to promote sustainability in general through reusability, or also to the use of green propellant. So what is TCAT? TCAT is a tool that was mainly made, started to be made as a version 1.0 during the Project Sunrise collaboration with OneWeb. And at the beginning, this tool was coded to work in a low orbit, modeling small satellites, and with the goal of optimized target fetching for constellation maintenance. This tool have the main objective of trying to provide quick trade-offs and to understand if some kind of missions are feasible or not. How the tool works: the user should define prior the simulation and architecture, so putting relevant orbits, the vehicles that will be included, which kind of phases, so maneuvers, will be conducted, and so on. And some kind of input that are also needed are some key information on subsystems, and in particular the propulsion system. At the end, the software will do a lot of simulation to combine these inputs, and at the end you will have raw outputs such as the ion with mass, power consumption, the delta V. And the goal is to have a ranking on the solution that we simulated, to understand which of this one is the best for the scenario that we want to simulate. After that, we updated this tool, reaching our 2.0 version. And in this version, we wanted to extend our trade space, in particular going to the moon scenario trade space. And as you can see here, we wanted to model three different scenarios, three different architectures of mission. So one direct to the moon, one that went through a hollow orbit before going to the moon, and a third one that had two different launches going through the hollow orbit and having a transfer module that transferred a mass from the hollow orbit to the low orbit and then to the surface of the moon. And so as you can see here, the kind of results that we have are in this way. So we can easily understand which mission is feasible or not. For instance, for 100 kilogram of payload, it was all feasible. But for the 500 kilogram of payload, it was only feasible the mission with the 2 launches. And as you can see here on the left, we can also have some results regarding the mass budget of the satellite, but also the overall mass budget for the entire campaign. And regarding the future development of TCAT, we are talking about the project Dawn. It's a project financed by ESA, and this is the project I'm currently working on. In this further version, I will say the 3.0 version of TCAT, we want to add some scenarios regarding the constellation deployment and on-orbit servicing. We want to do so providing a user interface because it was lacking of this capability before. And in this user interface, the user will be able to specify if he wants to simulate a constellation deployment scenario or a on-orbit servicing scenario. It will be able to specify or maybe select some kind of pre-selected constellation type, for instance, a Walker constellation or also a Starlink constellation, and otherwise he could also specify single orbits. Then it will be needed to specify the satellite characteristics, so the mass, the volume, propulsion, and so on. And considering also the ride sharing option, the user will be also asked to select if he wants to use a specific deployer or dispenser, or the software will give a random or pre-selected one. And then if there are some delivery constraints, so if we are Europe, we want to use maybe only European launchers or not, or if we have some time frame constraints. And at the end, we can also provide some information about the upper stage or last mile stage we want to use. Or again, if you want to leave this blank, the software will give you the right answer for this question. So there will be a lot of simulation so that you can have a lot of combination of these inputs. And at the end, the user will have a lot of graphs, a lot of table and so on to understand how all these scenario and how these missions are different and why you want to prefer one or another one. And to do so, for the constellation deployment, we will mainly focus on these 5 components. So apogee motors, upper stages, tags, space tags, and piggybacks and dispensers / adapters. And of course, we can also combine these components together. For instance, a motorized dispenser that it's like a tag and this kind of stuff. And just a little remark, we will mainly focus on the selection of the launcher, the launch pad, and this kind of stuff, but we will not consider the staging part because it's a launch vehicle provider work, I would say, job. And so we will mainly focus on the first part and on the last mile part, as I was saying before. Regarding the on-orbit servicing part, it's quite similar as before. There are some parameters that can be selected that are quite different than before. So I will not go in every of these boxes, but I want to specify that we will focus on these 4 kind of services. So refueling, life extension, and active removal. And this is thanks to ClearSpace also. And at the end, tagging. And this is all from me. Sorry if I was fast. If you have any question, I'm happy to answer to your question. I think now, because I'm the last one.
There is a question for Marlene and Flavio. How do you compare and contrast your approaches tools with Coquijos tools?
Well, of course, Coquijos tool approaches are, I would say, way more advanced than ours. And I mean, also because we started working on that from a few years. So I think that for now our tools are mainly helpful for like to aid mission design without needing optimization for now. So it's mainly devoted to visualization and aid in this sense. But in future, of course, I mean, I'm talking for me. The idea is to also implement some optimization, this kind of stuff.
Yeah, so I agree. With these patterns, they are extremely high level, in the sense that they're proposed to be really the first thing that comes after input of objectives. So the idea for them is just to be able to explore the trade space and pick out and generate options that are likely to be interesting to further investigate, and then apply tools that typically do optimization, for example. And because the patterns simplify the structure of the problem enough that ideally it would also be able to compare larger amounts of data and be able to design space mission concepts not as an isolated system, but in considering also what likely other mission designers would design, and if there are any possible synergies there to take into account. So that's really what this choice of pattern languages aims to bring as advantage.